Good morning, GLA middle schoolers. It is Mr. Manta again, and we are moving forward with another science video lesson. Today's date is going to be Monday, May 11th, and we're on to the lesson 15 of our chemistry unit here. That's pretty far into this unit. As you guys know, most of our units have had around 14 to 16 lessons, so we're getting towards wrapping this one up. Now, before we jump into today's material, I do have an important announcement, which is related to that. The announcement is that since we're kind of getting towards the tail end of this unit and the tail end of the school year, I want to help us not necessarily celebrate, but I want to wrap up this unit in a way that's really exciting. So, we have a couple more lessons this week, and then starting at the end of this week and all through next week leading up to our unit test, we are going to be doing not one or two or three, but four different at-home experiments. So, these are all going to be optional, so I don't want to force anybody to go to the store and buy all this kind of stuff if they don't want to do it. You will have to watch the videos and do the questions just like normal, but actually doing the experiments at home will be optional. But since there are so many of them coming up, I want people to be prepared so they're not running to the grocery store the day of if they want to take part in these experiments, and kind of give you and your parents the shopping list for these upcoming experiments. So here we go. We have experiment 1, experiment 2, 3, and 4. You can do none of them, you can do all of them, you can just do experiments 1 and 3, you can just do 2 and 1 and 4, any combination that you want. I just want to give you guys the shopping list for these household items ahead of time. So next time you're at the grocery store, you know what it is that you'll need to get to participate in these experiments starting at the end of this week and going through next week. So, if you want to take part in these, go ahead and call your parent over right now. Say, hey, let's take a look. Let's look at some of these items and see what we already have around the house and what we might need to take part in these upcoming experiments. They're all going to relate to some of the chemistry concepts we've been talking about, and they're all going to be super cool. So I would love to see lots of people doing them at home and sending me videos. Alright, moving on from there. I do want to start with today with a do now, just as we always do. We were picking up where we left off at the end of last week, talking about atoms and molecules and the differences between those things. So go ahead and pause this video and complete today's do now in your science notebook now. Alright, I'm now assuming that you're unpausing and you have completed that, because here are our answers. Number 1, when we say that matter is made up of particles, the two kinds of particles are really atoms and molecules. That's what we talked all about on Thursday. Number 2, the different types of atoms that exist are called elements. There's a whole bunch of different elements, that means different types of atoms, and they combine into molecules. Number 3, which are usually bigger, atoms or molecules? Well, molecules are bigger because molecules are made of a bunch of atoms that have all been put together, so they must be bigger. Number 4, how many different elements are there that we know of? This one you might have forgotten, that's fine. There are 118. Yes, you are responsible for knowing that number. And number 5, scientists arrange all of the elements that we know of into a giant table called the periodic table of elements. We showed it last week. Here it is again. It is one of the most incredible achievements of humankind to chart out all the elements that exist across the universe. There's 118 of them. There's so much information going on here that I can't even get into right now. We also, in case you're a little rusty on this whole atoms and molecules thing, I did also want to show this diagram one more time that explains the basic idea of how molecules are made of atoms. So here you have an oxygen atom. Oxygen is an element. Here you also have a hydrogen atom. Hydrogen is an element because elements are different types of atoms. And molecules, as we're seeing, are made of atoms stuck together. So a water molecule has one oxygen atom and two hydrogen atoms all stuck together, and it looks like an upside-down Mickey Mouse head, and that is why they call it H2O, because there's two hydrogens and an oxygen. Alright, moving on from there, and talking about some new stuff from today. If you remember, in the very early lessons of our chemistry unit, we talked about properties a whole lot. And when I was trying to explain why it is that chemists are so obsessed with classifying things by their properties, we talked about how you can use properties to help you identify things that you don't understand, that you don't know about. Mystery objects is what we called them. And whether that's a different, new species of animals, or the example that we used was Pluto, right? We know that there's this thing called Pluto flying around our solar system. We couldn't figure out if it was a planet or a dwarf planet, so we looked at all the properties of planets and the properties of dwarf planets, and that's how we determined that Pluto was in fact a dwarf planet, because it matched up all of its properties, but it was missing some of the properties of the planets. Now, I want to connect that idea from way back when, with all the new material that we've been learning about chemical reactions and chemical properties, to answer today's big question, which is going to be not just how can we use properties to identify, all kinds of mystery objects, but specifically to identify mystery chemicals. When we have a chemical and we don't know what it is. We're going to hop over to Crash Course. Listen up carefully. I will be recapping the important stuff, but I do need you to listen up and hear every single thing that our friend Sabrina has to tell you.
Let's say my friend and I have just gone to a birthday party, and we each got a gift bag that's full of candy. And my friend makes me an offer, one that I can't refuse. She says I can have any one piece of candy in her bag, but I can only take it without looking. Now, say I'm into gummy frogs. They're my thing. That's what I want. Fortunately, I have a secret. A science secret. When I reach into the bag, I can use the properties of the candy to help me guess. If I want a gummy frog, I'm gonna feel around for something that's kind of small, squishy, and, frog-shaped. But how else can we use this idea? I mean, in other non-candy related contexts. Does it work on school supplies? Breakfast cereals? Hardware? I mean, what exactly can we tell about an unknown substance by its properties? We already know that a substance is matter that's made of one kind of atom or molecule, and that has specific properties, and that some substances are elements, which means they can't be broken down into other substances through physical changes or chemical reactions. We also know that we can group substances and elements by their properties, like we found that all of the metal things from the bottom of my backpack were shiny and attracted to a magnet. So, metals have high reflectivity and magnetivity. What else do we know about metals? If we think back to our lunch investigation, we know that metals are good conductors of heat and electricity, and metals are often silver or gray in color. Let's try another substance. What are some properties of gases? Let's think way back to some of our first videos. When we talked about gases, we learned that gases have no definite size or shape. The molecules in a gas spread out to fill the container they're in. Gases are usually transparent, too. Light passes through them. If we think about some of the gases we know and love, like carbon dioxide and oxygen, we find that they have these properties. Both of these gases fill up the space they're in and are transparent. Gases and metals are just two examples of groups of substances that have specific properties. And because the properties are pretty specific, they come in handy when we're trying to find out about an unknown substance. So, let's get the investigation rolling. Say we have two unknown substances. Both look the same, kind of whitish and powdery. How can we tell them apart? Now would be the time to go over a truly important scientific rule. No tasting. Ever. Right, since that's out, what should we do? Think back to our picnic. Remember what we tried to do with sand and with sugar? We tried to see which dissolved in water. So if we took a spoonful of each unknown substance and tried to dissolve it, the one that dissolved would be the sugar. One of the properties of sugar is that it dissolves in water. Sand, as anyone who's been in the ocean will tell you, does not dissolve in water. It just gets into our bathing suits. But now it's time to level up. This time we'll look at two mystery objects that are totally hidden from view. Our mission, should we choose to accept it, is to find out which one is metal. If we use our sense of touch, we can tell that object A is not very flexible. It doesn't flex or give when I press it. Object B, on the other hand, is pretty malleable. It squishes when I touch it. Ew. So far, we can make the guess that A is metal, but in science, the more evidence, the better, because malleability, or the ability to change shape, is actually a property of some softer metals. So we need more data. Let's bring in our trusty magnet. As you can probably see, because I can't, object A seems to be attracted to the magnet, while B isn't. So, object A has the properties of being hard and being attracted to the magnet, so we're going to guess that it's the metal. And we're right! Object A is a big old nail and B is, hey, my gummy frog. So, substances and elements have specific properties, and because of this, we can use properties like hardness, malleability, or magnetism to tell something about, or even to identify, unknown substances. It doesn't matter if it's candy or handy hardware. And I'm out of gummy frogs.
Alright, one thing that video definitely made me do is want to go try some gummy frogs. I don't think I've ever had a gummy frog before, but I was shopping for them on the internet, and I might be getting some delivered next week. Who knows? All right. So to recap what you went over in that video, because a lot of it was familiar, but some of it was also new. The main key point that she was trying to make was simply that we can use properties to identify mystery chemicals. Now, in this case, her objects were a nail and a gummy frog, but you could say that this nail is made of the substance or the chemical, probably iron or steel, whereas the gummy frog is made of some kind of gummy and sugar chemical, right? And we've seen that before, that we can use properties to identify mystery chemicals. And some of the properties she looked at was she tried to squish and bend the objects and found that object A was not very malleable. And then she took a magnet and she put it to the object and found that it was magnetic. And based on the fact that it was not malleable but it was magnetic, she concluded that object A was metal, was made of metal. And then she took the blindfold off and she saw in fact it's a nail, whereas object B was her gummy frog, right? And she was able to identify that even while she was blindfolded, even when she couldn't see anything. That she had a metal object and a non-metal object based on the magnetism and the malleability that we were looking at, right? But, and what you're probably thinking is probably something similar to what I was thinking when she did this, which wasn't that kind of silly? Like, she could have just looked at the two objects to see what they are. A nail doesn't look very much like a gummy frog, right? Why do we, if we don't have a blindfold on, assuming that we can all see, then our property is really very important if we can just be like, well, that's a nail and that's a gummy frog. So I want to take this idea of using properties to identify objects one step further and inform you guys that there's a reason why we have to use properties other than just looking at things in chemistry. And that reason is, and you should write this down, our second key point, chemists often work with chemicals that you can't tell apart by looking at them. You can tell a nail apart from a gummy frog, but take a look at this slide right here. I have this beaker right here, this one, and this one. I'm going to tell you that these three beakers have three very different chemicals in each of them. Even though they look identical, one of these things, if you drank it, would be totally fine. One of them would make you sick, and one of them, in fact, would kill you. But I can't tell which is which from looking at the pictures. In fact, I would need someone who knew what they were to come by and label them and tell me, in fact, that this one on the left is water. And not only can you drink it, but you should drink it. You should drink water every day, otherwise you're going to be unhealthy. The one in the middle is a glass of vinegar, which we've seen before. And vinegar goes into cooking sometimes, but if you try to drink that whole glass, you'd probably get kind of sick. It would be a really bad day for you. And the one on the right is a chemical called hydrochloric acid. It is an acid, and if you tried to drink that entire beaker of HCl, you would probably die. But if someone didn't tell you that, if you didn't have that, no matter how closely you look at these three things, you really can't tell them apart. Another example would be these three white powders that I'm looking at here. They look a little different, but also pretty darn similar. There's a lot of different chemicals that look like a white powder when you take them out of a box. This one on the left turns out that it's just flour, and if you want to eat it, that's totally, you shouldn't eat it too much of it raw, but we bake it into bread, so we eat it all the time, and it's fine. This one in the middle is baking soda, and you probably wouldn't want to eat a big clump of baking soda, or if you try to eat too much of it, you would get sick, just like with the vinegar. This one on the right is a chemical called potassium cyanide. Potassium cyanide is poison, and it's something that assassins will try to use to poison their targets and kill them. So if you end up eating this one, thinking that it's this one, you would also be dead. Point is that these three substances all look really similar, and we can't tell them apart very well just by looking at them. So we have to think about some other chemical properties that we could use to identify these things if we didn't have someone right there who could tell us what those are. And that happens in chemistry all the time. Chemists will often, mix together three different chemicals or two new chemicals, and it will create something, and they don't know what that something is. It'll create some mysterious white powder, and they're trying to figure out what it is. Is it safe? How safe do I have to be with it? Is it dangerous? And they need to identify it, use its properties in order to identify it, because they don't have anyone who can just tell them what that thing is. So, in order to make this point even more clear, it is time for a demonstration. I have another video that I recorded today with a special guest that's making this point. So, we're going to cut now to Mr. Manta and also Mr. Manta? How can this be? Well, let's see. I have a special guest. You're going to meet him now. Alright, we're back on camera, and I, Mr. Manta, brought with me a special guest today. Would you want to introduce yourself?
I guess I'm technically also Mr. Manta.
That's correct.
I am Zach's older brother. So, here to help today. Excited about the experiment.
So do you think that like some of my students might have a hard time telling you and me apart?
I think your hair would be the giveaway. I think otherwise we look similar, but the hair is going to be the go-to. I clearly don't have that type of flow that he has.
Right, and if I cut that down, then we look we would look really similar. We would have the same last name, and it'd be really a challenge, right?
That would be very difficult.
Well, so that's fitting for today because we have a bit of a problem that has to do with telling two different things apart going on.
All right.
So, you know it's Mother's Day, right? I record these videos one day early, so the kids are watching this on Monday, but really it's Mother's Day here. And I wanted to like bake Mom some cookies or something for Mother's Day.
All right.
And I don't know if you remember, but the last time that we were baking, I realized we had these nice jars laying around that I wanted to use, and so I took some of our baking ingredients and I put them into these jars.
Okay.
But I forgot to label them.
That could be an issue.
So we have these two jars here. And there was this one that I found in the cupboard, and there was this one as well. And what I remember was that one of them is baking soda, and one of them is flour.
Okay.
But like looking at them, would you like take a would you think you can tell which one is which enough that you'd want to bake with them?
I'd be a little worried. Have a guess, but not confident.
It'd be tough. So, what do you think that we can do? Because this is a problem that chemists run into all the time, where they have different chemicals that look really similar, and they're trying to figure out how to tell them apart. What do you think that we could do to figure out which one's which?
I would say if you maybe mix them with certain other substances and see how they react, that might be able to tell you what they are.
Did you watch my video lesson from last week when we did that?
That was this the one with the glove?
Yeah.
I did see a couple of the gloves.
Nice.
Yeah.
Okay, so what do you think we can mix these things with, and how would that tell us which one's baking soda and which one's flour?
I think you would mix it with vinegar.
Yeah.
I think if you mix vinegar with flour, I don't think anything would happen.
Okay.
And I think if it's baking soda, it's gonna like bubble up, and fizz up.
Okay, so let's find out, right?
Let's give it a shot.
Do you want to do? So I got a glass for you here, and how about you do this one first, and then we'll try this one second.
Okay. Let's see what happens.
All right. So we're trying to figure out which one's baking soda, which one's flour.
Okay.
Take a spoonful of it, and we'll find out we'll see what it is.
There we go.
All right, and then
Sounds
we
very
have
official.
our same white vinegar from last time. We want to mix some of this in.
Okay.
We're not being very specific. We're not being the best scientists today. Okay.
That's pretty boring. Not a lot happened.
Yeah,
on
that wasn't very exciting. I know that the last time we mixed baking soda with vinegar, something a lot more exciting than that.
Yeah.
Right. Okay, so this one over here, we know that no reaction happened. So let's put that off to the side.
Together.
And then I'll take a spoonful of this one here in a separate cup. Dun, dun, dun. And we'll get that front and center. And then add some vinegar and...
See what happens on this one. Oh.
Alright, don't add too much.
Just don't want to bubble over, right? Make a mess.
I would say that's a pretty clear result, right?
Yeah, and you can smell it too. That's the other thing.
So we started out with a problem. We had said these two different jars looked very similar, and we couldn't tell which one of them was which.
Yep.
And now we've answered that problem. What do you think which one's which?
I definitely think this one is the baking soda based on what happened that we could see and how it smelled.
In other words, we would say that the baking soda has a chemical property, which is that it reacts with vinegar, and when it reacts, it fizzes and bubbles and has all those signs, and that smell that helps us identify that we're with baking soda, which means that one is...
So then this is just flour, because this didn't do anything. It's
Okay.
just kind of liquid and the flour mixed together.
There we go. Do you feel confident enough that you think we can go bake some cookies with these?
I feel pretty confident. That was a very different reaction between the two of them.
Nice. Sounds good. All right. Say so long.
See you guys.
Bye, everyone. All right. That's all we got for today. Me and my special guest, also Mr. Manta, second Mr. Manta, my brother. I want to recap what it is that we just saw right there, just so we get the main idea of it. I hope you guys enjoyed it. The problem was that we had these two different white powders that we couldn't really tell apart. They had more or less the same color. They had the same texture. They were both powdery. And neither of them really had any kind of smell. They smelled the same, like nothing. But we know, since one of them is baking soda, that one of them would react with vinegar and one of them wouldn't. So we poured some vinegar in with one of them, and nothing happened. And then we poured some vinegar in with the other one, and it fizzed up and caused this big reaction. That's because baking soda has a chemical property, which is that it reacts when it's mixed with vinegar. But flour does not have that chemical property. So even though they have the same color, texture, and smell, that's one chemical property that's different about them that we can use to tell them apart if you're getting them mixed up. So we know that one ended up being flour, and this one over here ended up being baking soda. And it's only because we can talk about properties that we could figure that out. We wouldn't be able to look at them and just see the way that Sabrina from Crash Course could see the difference between a nail and a gummy frog, right? Alright, that's wrapping us up today. I have 2 classwork questions at once for you, so go ahead and pause the video and answer these now. Why can't chemists just identify the chemicals they're working with by looking at them? Think about the pictures of these, these chemicals that we have been looking at earlier. Why can't you just look at those and tell them apart? Why do you have to think about properties? And second question, who do you think is older, Mr. Manta or my brother? Pause the video and answer these 2 classwork questions now. Alright, I'm now going to go ahead and unpause, assuming that you've completed each of those, because it's time for independent practice, just like that. We got these 8 questions. Go ahead, pause the video, and as you know, in your notebook, write out the answers to these 8 questions now. Alright, I'm assuming that you've completed that now. Don't let me keep playing if you haven't. Answer those 8 questions, and here are the answers. Number 1, when we say that matter is made up of particles, the 2 kinds of particles are really atoms and molecules. Yeah, we're reviewing a little bit from yesterday's lesson. Number 2, true or false, molecules are made of atoms, but atoms aren't made of molecules. That is true. Molecules are made of a bunch of little atoms put together. Number 3, how many different elements are there that we know of? There are 118. Keep on practicing that number. You are expected to know that. Number 4, yes or no? Can you break down an atom into even smaller parts? The answer is no. An element is defined by its atom. You can't break it down into anything smaller. Number 5, you can find out if a mystery chemical is metal or not by seeing if it's attracted to a magnet. That's what Sabrina did in the Crash Course video to identify which of her 2 objects was metal. Number 6, true or false? A good chemist is able to identify all the different chemicals just by looking at them. Well, that's false, because there's a ton of chemicals that look exactly the same, and you need more information than just looking at them to tell which one is which, no matter how good of a chemist you are. Number 7, true or false? If a liquid looks like water, it's probably safe to drink. Oh my goodness, that is false. As we saw, especially in a chemistry laboratory, if you have a beaker of hydrochloric acid or something that might look like water, but it is definitely not safe to drink. And number 8, you can find out whether a white powder is baking soda or flour by seeing if it reacts with vinegar. That's what we mixed in with it to cause that reaction. Go ahead, star those questions you got right, fix the answers you got wrong, and tell me which ones you got in the classwork video or the classwork forum today. And that brings us to our exit ticket. That is all that we got. I hope some of you guys are starting to assemble your grocery lists of experimental items to begin to acquire. And I want to point out today's cool thing. Since I was hanging out with my brother, we aren't twins, but we maybe look a little bit alike, and we were talking about having the difficulty telling 2 different things apart. And so I wanted to link to you guys today's video, which is a video of 2 long-lost twins. These 2 girls are identical twins, but they were each adopted when they were younger and went to separate families and grew up all the way to, like, however old they are, 12 or 13 years old, without ever having met each other. So the video that I link is a video of them 2 meeting their twin sister for the very first time ever, which I thought was really cool. Alright, that is all that we got for today. Go ahead and knock out the classwork questions, the exit ticket, and all that good stuff. And I will talk to you guys tomorrow.